Welcome to today's webinar on revolutionizing IT decommissioning. Before we begin, a few housekeeping items. First, this webinar is being recorded, and a link to the recording will be sent out after the event. All attendees are in mute mode and will remain muted for the duration of the webinar. If you have questions, use the Q&A button. We will try to answer all questions as they are submitted. If there are questions we do not get to, we will answer after the webinar via email. I'd like to introduce today's two presenters. Keith Parent is the CEO and co-founder of Square Group, and Brian Reynolds, the CEO of Docxonomy. Guys, take it over.
Thank you, Roy. I'll introduce myself. My name is Keith Parent. I am the CEO of Square Group. We are a managed service firm managing IT infrastructure for life science companies. We can manage applications all the way from preclinical all the way through manufacturing. And as such, we deal with a lot of different technologies and a lot of different vendors working with our tools. That's when I met Brian, and Brian and I have been doing stuff now for a good long time here. So Brian, how about kicking it off?
Sure. Yeah, my name is Brian Reynolds, CEO of Docxonomy. So Docxonomy is it's basically an AI engine really designed for doing AI-powered solutions, I guess is the best way to describe it, right? We use it for rapid deployment to, if you think about any kind of content that you have within your organization, unstructured and structured, and being able to process that content directly through and gain insight and intelligence on it, much like a human would do it, but utilizing machine learning and AI algorithms and large language models and things of that nature. We've got a system that's in place that simplifies that, makes it easy to rapidly get up and running, and can help generate ROI for businesses across the board. And today we'll be talking about application decommissioning, because that's just one of many things that the platform provides value around. And we'll talk about a couple of use cases where some pretty large organizations were able to save a significant amount of money by making that transition. Oh. There you go, Keith.
Hey, thanks. So one of the reasons that Brian and I got together were, first, we have a product that we actually work with a lot of our clients on called RegDocs 365, which is a regulated content management solution. And we were looking for a specific solution for one of our clients, particularly to search across documents within a repository or multiple repositories that can search in multiple languages. I had been looking for a solution, and I came across Brian's group as part of something, because we were working at a couple different areas, and what we wanted to do was figure out, can we put this into this solution together? And I looked for a lot of different solutions, and when I saw Brian, he basically said Docxonomy has that nailed. We've got that down cold. So from a starting point, I said, okay, that's great. We can actually do full text searching and things like that, but we didn't have the multi-language capabilities. We didn't have the similarity searching. We didn't have the AI-based mechanisms that were there. And one of the great parts about working with Docxonomy and working with Brian in general is, as we're looking at different solutions, we come up with even more opportunities to basically either use methodologies that we've identified, or come up with potential ways of doing things far more advantageously than we could have if we were doing custom code or anything like that. So I think in this regard, we're going to be doing a series of webinars. We already did one that talked a little bit just about the searching capabilities, and we want to try to get away from just searching, because searching is kind of passé. A lot of people can search for things, but we really want to talk about searching multiple repositories, using AI to help drive insights into data found in multiple repositories, and be able to come up with the actual solutions that can make a difference. I think it's great to have tools, but unless you have a tool that you know how to generate a solution from that tool, that's what's going to be the driver of real change in an organization. So working with Docxonomy, we're able to come up with a couple of things. this seminar or this webinar today is really going to talk about intelligent archive, which we'll get to in a few minutes. But we also want to talk about intelligently using data out of multiple repositories to feed into other systems, generative AI, and how can we generate content from systems that are in other content in other systems, and pulling all those together. So we are going to be doing a number of these kind of webinars talking about how we can use both RegDocs and Docxonomy together to not only use a workflow engine, but basically see the data flow between multiple applications and pull it into other applications. Brian, I'll let you take it from here, and we'll talk about basically the way Docxonomy works, particularly around looking at multiple sources of data.
Sure. Yeah. Thanks, Keith. Yeah. One of the things that we wanted to talk about today was really how easy it is to connect and analyze and archive data. So we're talking in an archiving standpoint today. And of course, this same data that we connect to doesn't necessarily have to be data that's in an archive. It could be data that's live data that's in a system that you want to gain insight on. It doesn't matter what repository it's in, whether it's in content management repositories or databases or other source applications, SAP, things like that. All of that data can be aggregated and brought to a single point to where you can very rapidly and intelligently understand it. But in the context of archive, when you're wanting to decommission applications, it's important to be able to, utilize pre-built connectors that we have in the system, which we'll actually demo and show today, and look at how we can easily configure those, set them up, and then have them crawl the repository, extract the data that's in the repository, again, both structured and unstructured data, and then be able to report on that data, be able to query that data, be able to extract it back out. Because a lot of this data that you have, it's regulatory in nature. You need to keep it for a certain amount of time. It could be life of product. It could be life of company. There's a lot of different factors in a retention schedule that determine why you need to keep this information. But it's also very expensive to leave this information setting in older systems that become disparate and get old and aren't needed and just don't work, right? Only a handful of people know them, and you have to pay a pretty large fee for keeping them alive. I think Keith, Brian, you had an example of that.
Yeah, I think, Brian, a couple examples that come to mind right away for me is that in our data center, we actually hosted a system for one of our large pharma clients that was a Zybion system that we had in there. It ran on a VMS platform. I'm an ex-Deckie, so I could actually log into VMS. But we had that system for almost 10 years within our data center, specifically because, number one, it was very difficult to export the data into something else that could actually search through the data. So that was a hard part about using that data. And number two, they had bought new systems and everything had transitioned over to a newer system, and they didn't want to migrate the data out of these because they want to put new applications into them. So basically, they kept this system around for years, and toward the end, I was the only one that could actually log into it from our side to support it. The customer would get in once a quarter, run some reports, and be pulling out. And it was all tied to a couple specific drug products that they had that were tied into this application. It just seemed like such a waste to be able to waste a whole rack in a data center with all the machines that we were running for that application that basically didn't get used for that whole point in time. One of the things that when you look at solutions with the Docxonomy tool, the concept of IT decommissioning, or what we're calling intelligent archiving. How do I intelligently look at archiving data and being able to use that data? Most people think about archiving solutions as it's a system that's out there, and one of the reasons I have to keep running it is because I can't migrate the data, or the system that we're trying to put it into doesn't support that data, or it doesn't have a follow-on, that the company that we were using went out of business, but we can't get away from that. I can tell you today, there's many customers that I know of that are still running applications that support for those applications has long since been abandoned, and nobody's using those tools. But people are used to things. People hate change, and they'll use these old systems for very long periods of time without thinking about what they're gonna do to do that. Or if they're gonna upgrade, they just get a new system and don't really think about upgrading it, and they'll keep the other one running in parallel behind it, knowing that they're not gonna put anything new into it or do anything with it, but at the same time, they still need some of that data.
Yeah, and that's actually a perfect segue to the use case or the ROI case that we were have put together for a customer and then ultimately archived them. We've done several of these, these intelligent archives, and they've been met with overwhelming success. Primarily ease of implementation, getting up and being able to perform it, and then really ease of being able to get at the data and utilize it and beginning to see insight that they didn't know before. In fact, this one customer we put together for the webinar today, they had multiple different systems. So they had some legacy Docxonomy system. They had legacy Microsoft SQL database that had a lot of data tied into it, some file shares, a couple of M&A applications. And they were keeping all of these running. And based on the licensing costs associated with running these, and the only reason they were keeping these systems around, as you were saying before, was for regulatory purposes. And like you said, once a quarter or whenever they got an audit, they would have to produce information out of the system. So they were paying a significant amount of money to keep these systems alive. In fact, I did the calculations when we worked with them. Their software maintenance cost was about $775,000 a year for the licensing associated that was running on these different legacy applications. And then they had just under a couple of FTEs assigned to doing the maintenance, right? Keeping them up to date, backing them up, making sure they're running okay, checking, drive, stuff like that. So when you added those two components up, they were spending just almost $1 million a year to keep these legacy systems running. And there was really no need for that because, again, they had already moved on to new systems and they were already using those systems in their business processes. And this was purely for, backup and retrieval, if you will, for regulatory purposes. So when we came in, we looked at traditional archiving solutions for them. They asked us to do kind of an analysis of one in particular they were looking at. And that particular one, I'm not going to name names, but, it was one of the more, we'll say robust or more known solutions that, were out there. And so we got pricing on that from a software standpoint. And in order to run the amount of data that they needed to put into it and set it up and configure it, the software license cost alone on that was about $250K a year, which, albeit is a lot better than $1 million a year, right, that you're currently paying. So if you can get to there, the one problem is that these other solutions, these archiving solutions, are very complicated and they're hard to get configured appropriately. You really need to sort of think through all the various different scenarios that might exist on how you want to retrieve that data, even though you're not quite sure how you're going to want to retrieve it. And once you make that change, you're stuck. That's it, because everything else is gone and there's no way to go back and there's no way to transform it in any other way. So that was sort of a limitation around that. But when you looked at that, the other side of it was going to take them a year-long project incorporated into that. So that meant you had another year's worth of your existing costs. So you had to not only buy the software up front, but you also had to have another year on there. So you were looking at about, $1.2 million just to get off of these systems in that first year before you could even start looking at, getting some of that return. When we looked at our solution against it, because that's what they asked us to do, we looked at total storage, we looked at 500 users. That's how many people they wanted to be able to have access to the data, which is not very much for us, pretty small scale. But then we look, that would be that we could accomplish this project in less than the time frame. We could be up and running. For purposes of this, we had put down that we would do it in 6 months. We actually were able to achieve our result within a quarter, so it was even better than that. We were able to get completely archived over and off the old system onto our system within a quarter, and that included working with any BAs and any knowledge around those systems, so we could make sure that we constructed it in the best possible way to, make it retrievable for them. But our software costs significantly cheaper, right? So we're only $50K for this particular footprint. So when you look at the total cost, to go with our solution, it was only $542K, not including project or consulting costs. And so, but significantly cheaper than the other option.
Before you go off on this particular slide, you go back to the last one.
Sure.
One of the questions that I had, because when I first started working with Docxonomy, I saw Docxonomy as a searching tool and being able to get to data where it was sitting in its own systems. My problem with the concept of intelligent archive is it would seem that if I'm going to have data still in those systems and I'm going to index into them and look at the data, that I'm still going to have to maintain those systems that are out there. So I don't see that as using intelligence to search through the existing ones, and it doesn't cut my costs down. Since you and I have talked about the fact that you're now going to be migrating some of that data as part of that process. Let's go through some of that. But before we get there, when I look at different databases, I think in terms of what you've got here, Documentum and a legacy database for Microsoft SQL, Linux, Oracle, Windows. The issue that I have is that sometimes people don't have those people on staff that can manage those. And I think that's another reason why having a single solution that is managed without having to have each of the individual people running them is another place that you don't think about some of the costs that are involved in some of that, but there's a huge cost involved in that. In this case, my issue is, how do you know if I get into a legacy application or a third-party application that you don't have the database schema, how do you set up your connector to make those kind of things work? Can you talk about that just a little bit?
Yeah, sure. I mean, it gets a little bit, there's a little bit on the consulting side with that, because you need to bring together, the IT staff that are around, clearly somebody's supporting and keeping, the system on, any business knowledge that may exist. And we sit down and we talk through that application. And there isn't an application that we can't deal with. Our largest one today, our largest archive today, in this case, has just under 12 billion objects in it, data objects, and over 8 million documents that came out of Documentium repositories, multiple repositories. But what we did in that process is we sit down with them, we work through, we understand what the application was, what it was doing from an interface standpoint, what was the essence of that structure. And then we build the queries around it and then map them into the system and then migrate the data. And in that process, we set up, it won't be exactly like, it's not like we build the UI of the existing application, but we give you a way to visualize it as you would expect to see it within the platform. So then when all that data migrates over, you can decommission the application, you can get rid of it, you can take down the database, get rid of it, you can turn it off in essence, stop paying the maintenance, stop paying licensing, all that, and the Docxonomy platform becomes the source for the content, and there you go and interact with it and find it, and you can then report on that, extract it, make it available for auditors if you're being audited, things like that. And we'll show some of that when we get into the demo in just a little bit.
Right.
So in this particular ROI case, what we saw was, clearly a breakdown, right? So when we looked at the traditional archive, it was going to be about a $2.2 million endeavor, including, consulting services on both sides. And again, this was consulting and internal resources, applied, versus about a $762K, which is what they went with our solution. So with the original cost being if they did nothing, the status quo being at just around $1 million, and we're being at $750,000, the return on the investment, they began to see a return in the first year. By making this transition, they actually were able to have about a $250,000 return on investment come back out of that after paying for the system. And then subsequent years, they were able to get almost that full million back because their reoccurring cost year over year was just the 50K for the software now that it's running. Now they've gone on and since expanded the platform and they've started to do many other things that our tool does besides just archiving, because once it's in place, you can begin to extend it to do all kinds of other things. And they're using it for many other things now. But this was sort of the catalyst to bring it in for them, and it worked out quite well. With that being said, I think what we should do is kind of shift over and let people sort of get a look at what the application looks like and sort of what archiving is. And I don't know any of those that are on the call that may have set in one of our sessions. You'll be familiar with this interface because it's the same interface, the same platform that does so many different things. Is the same interface that we go to interact with the data that's been archived. So in this case, we have within our demo environment here that we're running, we've loaded up several different kinds of data within here, different sources of data. We've got Docxonomy data, we've got native data that's been loaded directly into the system. We've got a couple of databases and some file shares. And so the idea being that it's a mix of different things. So you can see that. But what's something that we haven't talked about in past webinars was around the structured side of data. So today we're going to focus a little more around that because a lot of companies have these databases that are applications that don't really store content, but are in fact data. So for purposes of our demo today, we have a couple of different data structures that we loaded from the adverse event reporting data that's publicly available. And we're going to focus in particular on the events themselves from the FAIRS database. So we can go ahead and select the FAIRS database. We're going to go ahead and do a search on, we'll just say in this case, blood glucose. And that's all I'm going to do for right now, just a straight search. And so what we'll see here is we'll get back these data records that are coming back. These are not documents per se. They're actual, adverse event records as we've categorized them here. We can open those up and we can take a look at them. We can see the structured data that we're displaying here. And there's any number of ways that we can set this up. Simple name value pairs, lists of data, complex grids that you can do pivot tabling on and things like that with the data itself. But it's a way of being able to interact and work with the data. We can do data referencing and linking. So while this is a particular adverse event that occurred, we can see it's tied back to a specific drug, in this case, the Jardiance drug. So we can jump to that, that resource. So all of that kind of mapping from a table perspective that would be inside of a structured source that we're archiving over, we can maintain those relationships and give you a visibility into that. But we can also look at the data in a different way. So we can look at it from an insight perspective. For example, if we flip on to our insights, we can see we're no longer looking at individual specific records, but we're looking at salient data points across the entire repository, the result set. So there's represented in this particular view, there's 1,700, a little over 1,700 records, but we can start to see, okay, what is the highest patient age, right? That we see inside of that data set. And so we can begin to build these. And these are all configurable and tied back to aggregations and how we set the system up. What are the salient pharmaceuticals that are being mentioned, Plaxviv and Farxiga and so forth, right? So we can see the, kind of view that way. But what's more important is when you need to extract that data. And let's say this is archive data, it's audit trail data. It could be pretty much anything that you need to store within the repository. But when we set up those aggregators, we could go back in and say, okay, well, I want to build a report because I've been asked to look at this report this way. So I could choose, say, company number, let's say safety report ID. I want to pull that patient age and I want to pull out any reactions because these are data points that I have that are in this repository for this data set. So now when I run this query, I get a different view. And so what that view is it builds a grid out. And so I could begin to see my information much like I would see it from an Excel standpoint with various different points inside there. I could do some pretty cool things around this, like slicing and dicing the data. So I could group it by patient age if I wanted to, and then I could navigate through it and look at my data records, so, by age. I can sort and filter and do all that kind of stuff that I would want to do on here. But in the case of an archive and an audit and being able to report on that audit, I may need to extract this data. So with that being said, I could either, if it's a small enough amount, here we've got 1,700 records, I could go in and just export it right to Excel from here. If it's larger than whatever my number is set here, which I can increase that number, I can also go in and just do a batch. I want to get it all. And so here I could give it a name, batch report. And then I could choose a delimited file or JSON-L-based file. In this case, we'll say delimited, and then I could say, okay, go ahead and create. And so what that will do is it'll queue up in the background, and asynchronously, it will process that data, build a report, and notify me when the report's ready to be downloaded.
Now, Dave, now, Brian, one of the things I think that we want to make sure people realize is all of this data coming from a single source, or is this coming from multiple sources now?
This data is all coming from multiple sources, single source in a sense that they're coming from Docxonomy Index, right? But the data itself was archived in from multiple different systems.
Well, let's talk about that again. So when we first talked about intelligence searching and going through data, we were looking at data within its own systems. When we're talking about intelligent archiving, you've mapped out those systems, but at the same time, when we've created the archive, you've actually taken them out of those systems and put them into a single structure so that now when you're querying against your intelligent archive, it's only going against the one thing. You've shut down those old systems, so nobody has to maintain those systems, and now
Correct.
It's running right out of this engine.
Correct. That's
But
exactly right.
Okay, your engine, with this being the case, and have my intelligent archive of all my old data, and as I'm doing new systems, I index into my new systems and then cross over old data and new data.
You absolutely can, right? So we can crawl live systems as well at the same time, not in archive mode, but in synchronous mode, where we manage, updates, deletes and new records added, right? And keep the system in sync, and they can coexist together in the same place.
So I think that's an important point to make for people when they're looking at intelligent archiving. We're allowing people to get to all the data and look at all the data, but at the same time, you could lock it down and it could be read-only data for that point. You could still tie it in with live systems, synchronously set it up so that as those systems get upgraded and new data gets put in those systems, you could cross that over your old data at the same time as you're looking at your new data being generated by other programs you have going on.
Absolutely. Well, and you can normalize the data as well from within this interface. So maybe in the new system where your current business processes are running, you may have named fields a certain way, but in the old legacy system, you named it a different way. Same data, but within this interface, we can go in and map those two together to the single name that you want to call it. And then that way, when you're querying, even though you're querying a legacy system, you're still going to get all the view, even though one is an archive and one is a live system. And that's all built in by design.
I think what's really important about that, Brian, is that when people think about M&A activity, a lot of time, you've absorbed another company, and at one point you're running parallel systems there. This is an opportunity where instead of having to run these parallel systems, we could set it up where you could actually archive those systems into an intelligent archive and then still be able to get at all that old data. And now with what you just said, I could actually normalize it against the new naming convention that we're using at the new company and be able to get at that same data across different companies, which is that's a powerful message when you're looking at, particularly if you're a larger, pharma company buying a little small company or something like that. Sometimes rather than migrate all that data, let's just put it one place where we can still get at it without having to do something. You can always, in the long run, pull it into newer systems if you need to, because it's still sitting there. But at the same time, maybe you don't need to do that. Why duplicate some of that data if I don't need to? As long as I get to it and compare with it, that's a great way of using the concept of intelligent archive.
Yeah, exactly. In fact, a lot of times in the migration process, I mean, a very common thing in the life sciences space to have to migrate data from one system to another system, whether it's M&A, as you were just discussing, or it's just upgrading to new versions due to the regulatory practices of in validation and so forth, right? It's a pretty rigorous process. And a lot of times that data gets stale, old, stuffed into what they call legacy cabinets, right? Yeah. And what a lot of times we've been used to go in and analyze that data, understand that data, and then yeah, we can build extracts just like this that can be used then to pipe that data that you're saying, okay, I didn't even realize I had that, and it really belongs in, say, Viva, or it belongs in, you know, Documinium, or wherever it is that you store it. And then you can use the intelligence that was gathered to do that migration intelligently and send it in. We're not a migration tool, that's not the point, but we enhance the migration process through that intelligence.
Well, I think just that data mapping aspect is a huge thing. I know that there's been
Sure.
huge projects just trying to deal with that alone.
Yeah. Yeah. Oh yeah, absolutely. We're involved in some right now. So, but yeah, absolutely. So yeah, you know, from a archiving perspective, it's pretty simple to set up on the back end. Not very complicated. You know, in this environment, you'll see we have some set up already. Let's say, for example, we wanted to simply call a file share. You know, we would choose a file share connector from the system. We would give it, you know, a name, you know, legacy file share, whatever you want to call it, whatever it was called. And then in this case, in order to turn this into an archive solution, we say we want to keep the native content and we want to put it into archive mode. And the difference between those two components is that in synchronous mode, what it will do is keep everything up to date. So if you were to delete a record in the source system, it will remove it from the index. If you were to, you know, edit a record, it will, you know, update it in the system. So, but when in archive mode, it starts bringing stuff over, but it does not delete anything. It doesn't get rid of anything. It keeps everything that it brings over. And it keeps a detailed audit trail of everything that's being brought over in the archive. And that's important because at the end of a run, you want to take that data and do validation against the source system and us as the new target system and make sure that you got everything. Now, it's hard to look at everything, especially when you're migrating millions or billions of rows of data, which is possible. But that's where a lot of the AI side of what we have in the intelligence comes in. We can configure what we call pipelines, and a pipeline can consist of several different components that can be utilized to analyze and look at every single record, not only in comparison from a similarity standpoint or from duplicate matching and things of that nature, but even with an LLM where we can create very tailored prompts and actually have the LLM that's built into the platform analyze the data that was brought over as a pair of eyes that looks at everything and points out anomalies so that the human in the loop can just focus on what's different or what didn't come over and begin to make those assumptions as to why. And there's all kinds of reasons that things cannot come over, security reasons, lockdown, you know, encryption, stuff like that. But it can help you identify those, in essence, the needle in the haystack very quickly.
Excellent.
We also support the ability to set up permissioning. So as your data comes over, it's archived data. Maybe it has secure groups on that data, a way of managing who can see it and so forth, whether it's managed by the LDAP that you currently use. If it's integrated at that level, like Active Directory or something, we can use that. If not, we can set up security to mimic what the older system supported so that when we bring the data over, it's still under the same security level as to who can see what. Scheduling capabilities to determine how often to run, any kind of dynamic linking, and then of course mapping of what is it that we're calling. If file share simple, we're looking at paths. Database is more complicated. We may be adding SQL queries and querying the data and pulling it back and things of that nature.
You know, Brian, I wanted to bring up a point I think that you made a little bit earlier. You talked a little bit about the audit trail and the fact that when you're pulling the data over, it's fully audited, has a full audit trail, and it's there for everybody to see what's there. I think one big thing to note, a lot of the audience may be asking the question, well, is it going to hold up to scrutiny of the FDA, or is it going to, or the auditors when we're looking at it from a big pharma company as we're dealing with the FDA? The FDA is actually using this system, aren't they, Brian?
Yeah, the FDA is a customer of ours. They use the system in production today at the FDA. Currently today, we're managing promotional marketing materials. So in any commercials, any video, any podcasts, any websites, any kind of rich media type stuff that's being produced by any company that's being submitted back into the FDA, it's all running through a Docxonomy system and being analyzed. And then they're comparing what's being said in these types of media back with what the actual NDA in essence, right? All the documents associated, the approved documents, if there's any discrepancies or things aren't aligning properly, and they're using Docxonomy for that. We're also in the process right now of taking it agency-wide. So they're going to begin to utilize the platform across multiple different areas within the FDA. So even in the submission process. So, but yeah, they use the product today.
That's great. I think that's fantastic.
Yeah. So, I mean, those are, archive is archive, it's not, it's not the most sexy, glamorous thing, to look at, but it's also an area though that you can save a tremendous amount of money. One of the largest implementations that we did, which I talked about a little earlier, where we migrated a huge amount of data. They had 30 systems, Oracle systems and Oracle Documentum systems and Documentum Alone systems. And they had 30 different applications running, and they were spending literally millions of dollars a year just keeping those legacy applications alive for regulatory processes. They were able to migrate all of that content into a single repository of this platform, all of it living in one place. They could query it with results coming back in less than 1 second. So, it handles scale, so there's not an issue there. And they were able to cut the millions of dollars. I forget the exact number, but it was, multiple millions of dollars per year that they were paying in licensing and support for these applications that they shut down. They were able to cut that down to, I think it's about $150,000 a year now that they pay. So that's real return on investment. There is a need for it. Many of these companies are have the same, problem. And I think it's an area where we can definitely help.
Based on your FDA example, I think another thing to note for people is that because you can archive lots of different media type, it's not just documents. You can also take, let's say it's all old commercials or old videos that you had for product that you want to put in. You could actually archive all of that within the system too. And I don't know that people understand that upon ingestion of some of those types of data, you will actually transcribe some of the data that's on those. So you can actually search across some of those videos and some of those different types of media and be able to find information that you may not be able to find anyway in any other tool. And you can do that as part of an archive of those old systems.
Yeah, exactly. One of the examples that we give on that, which I think is helpful, is like if you do, say, an image search. So let's say we search for the word baseball player on an image search. And this kind of helps show off what you were just talking about, I think, in a good way. So you get back a bunch of images, regarding a baseball player within the image search, because we do image detection. And when we drill into that, we'll see that, we've made some predictions based on our AI model that this person's playing baseball. We've also picked up in this particular frame here that there's text, and we've OCR'd that text, so that becomes part of the index as well. But what's more important is what you were saying is this is part of a video, right? So that's the depth in which we analyze video, and we do that transcription. So anything that you search on could bring you back to a specific area, and all these segments would come up. So and then you could jump to any one of those segments.
And call your doctor right away if you have symptoms of keto.
So like if you know, we're searching on ketoacidosis, you know, and you got a hit here, we could bring you right to where that was actually not shown in any way on the document itself, but only spoken within the video.
That's awesome. No, I think the functionality in this system is dramatic, and I think that the concept of coming up with point solutions, in this case, we're talking about Intelligent Archive. This is just one of many solutions that we can come up with using this particular tool. So I encourage everybody out there, if you have questions, please ask. If there are no questions, we can end a little bit early today, but I wanted to make sure that everybody understood that as a tool, we are always looking for the capabilities of pulling data out of multiple systems and pulling it together. I don't see any real questions in the Q&A section. I've asked a lot of questions because I'm pretty inquisitive about how this thing works. But I think that in the long run, I think that we are going to be doing other webinars showing specifically how to take live systems, not archive systems, but live systems that are being constantly updated, but being able to use that data and pull that out of some of those systems and feed that into other systems. So I think that'll be another webinar that we do. Another capability that we want to talk to in the future is going to be 0 to first draft in minutes rather than weeks and months. I think that's something else Brian will be talking about. And the whole concept of generative AI and people wanting to know, what does that really mean? We want you to be able to use your own data to generate new output, whether it's a protocol, whether it's a report that comes out for a drug submission. How can we use your data within your systems to generate some of those capabilities? Brian, you want to just add a little to that while we close down?
Yeah, absolutely. I mean, in fact, I think that's the next webinar that we're doing is actually on that, the generative side. And really the whole idea behind it is really, it's to do AI at scale. So everybody is on fire with ChatGPTs and LLMs and the power of what they can do. And, you know, the area is growing quite rapidly, which is, you know, been really awesome. You know, like I said, we've been at this for 7 years already. And so we're pretty ahead of that curve, but others are getting caught up and finding it, you know, seeing the power of what it can do, but it is kind of the wild, wild west. And so how do you control that? You know, how do you control that process and how do you put it at scale so that the output is something that you can trust and rely on? And of course, you still need the human in the loop. It's not about, you know, removing that human, but it's about taking out those mundane sort of rudimentary steps that your knowledge worker has to do today that they dread and probably don't do as well as they could do, but you know, because it's boring. And to be honest, that's just the truth. It's taking AI and driving those things forward. So, and we'll be showing use cases around different document types where we can go, for example, in the labeling side, to go from a core data sheet within your company to generating SMPCs and USPIs all on the fly. Through prompting, through dictionary lookup, through, you know, managed components, through unstructured data that exists within your repository, but it's your data that drives it forward. It's quite powerful and look forward to sharing it.
Awesome. Roy, do we have anything else that we want to go over?
No, so we will be sending out a link to the recording. And we thank everyone for attending. Thank you, Keith and Brian, for a fantastic educational event. And thank you all for attending.
Thank you very much.
Have a great day.
Talk to you later. Bye.